Hello fellow makers and welcome to Hypermakes. So you own a Voron Switchwire and things have not been great. Especially if you own a Switchwire conversion mod, then you probably use a salvaged Ender 3 bed. As the stock bed is made out of thin aluminium, it turns into taco way sooner than you have thought. To tackle those type of issues, bed mesh leveling is a good approach. But when it comes to choosing a probe for the same, the inductive probe is a thing of the past, as it is very inconsistent in terms of triggering distance and sometimes it totally fails due to the constant heat of the hot end. Brims act as a quick fix but lead to wasted filament. Then what is the solution, you ask? Join me as I assemble the new Magprobe HX with you guys. So before we assemble the Magprobe HX, let's see some actual good probes that you can use with your switchwire. There is the quick draw for switchwire, which is inspired from the original Annex Engineering quick draw probe, or the clicky probe, which uses a servo mechanism to dock the probe. But both have their limitations, as quick draw limits the travel of the tool head in x-axis, leading to reduced print volume, and clicky is very difficult to access when you decide to enclose your switchwire. But there is another probe that is very less explored, which is easily accessible and does not reduce print volume. I am talking about salveoo's Magprobe. Magprobe uses a servo motor similar to clicky probe to deploy and dock the probe. It is seated near the print bed, which simplifies the docking procedures. But as I mentioned, it is seated near the bed, it keeps getting cooked throughout the print job, which leads to failed microswitches over a period of time. As a result, I decided to design Magprobe HX, which uses KW11 or similar compatible microswitches, which are more resistant to constant heat cycles. So without any further ado, let's get into the assembly process. After downloading all the open source design files from salveoo's repository, I used Fusion 360 to design my remix of Magprobe. If you are wondering about the design files of Magprobe HX, they are available in the repository linked in the description. This is the probe block in which the KW11 microswitch sits inside. This is the probe arm which will be attached to the servo motor for the docking procedures. This is the servo holder in which the servo will be fitted to. This has two variants to choose from, one for the stock switchwire and another one for the switchwire conversion. This is the carriage mount which will be attached to the printer toolhead for docking and undocking procedures. And finally, this is the modified X-axis cable chain cover which will be used to trigger the Z-Max end stop for my switchwire. Starting with the assembly, first we will prepare the modified XZ cable chain cover with a M3 8mm socket head screw and a M3 T-nut. Now place it on the X extrusion similarly like the old one and make sure to adjust its position so that it is triggering the Z-Max end stop. Here you can see the Z-Max end stop being triggered by the cable chain cover. Now, prepare the servo holder with two M3 8mm buttonhead screws and two M3 T-nuts to attach it to the side extrusion of the printer. Place the servo motor inside the servo holder and fix it using two M2 self-tapping screws. Finally, attach the servo holder to the side extrusion. Make sure it has clearance from the bed and moves freely. Now for the probe arm, take a M3 8mm socketed screw and screw it inside the probe arm. This will help the magnet in probe block to grab onto it while docking. The probe arm has built-in supports in place to minimize the use of external supports while printing. Use the provided screw with servo motor or a precision screwdriver to poke a hole in it. Attach the probe arm to the servo motor and secure it using the provided screw. Adjust the height of the servo holder in such a way that both the probe block and the probe arm do not touch the bed of the printer. Now for the carriage mount, wrap the wires through holes and secure them using two round N45 magnets. Use a small zip tie like this to help the wires from being pulled while installation. Use two M3 8mm socket head screws to attach it to the exit gantry. Now finally for the probe block, there are some points you should consider. Use 0.12 layer height if possible for better structural finish. As the tolerances for this part is very tight, you may need to remove some print imperfections using a utility knife to avoid breaking of the part when installing magnets. If your probe block has a droop like this due to insufficient cooling of overhangs, you have to remove it, or else it will lead to a broken probe block like this when installing magnets. Now take your KW11 micro switch and put it inside the probe block, minding the orientation. Make sure the bottom plunger is facing away from the slot of the magnet. Now insert the magnets in their place one by one. Use a flat surface to make the magnets parallel to the contact surface. Here is how your finished probe should look like. Magprobe HX uses a similar approach as Magprobe but with better and optimized configuration. All the macros used for the probe are properly documented and are placed in a single config file. It has a standard deviation of 0.001, which is similar to the other probes available in the same segment. All the design files and the config file are available in my GitHub repository, which is linked in the description. If you have any kind of feedback or questions, feel free to mention them in the comment section. Like the video if you found it helpful, and subscribe to my channel for more future videos like these. Till then, take care and see you in the next one.